Alright class, in this video we're going to find the Laplace transforms of Heaviside functions. So there are two formulas that you're going to see in the book, okay? And the second one is the one that's stressed, but and you can use it in the way I'll tell you here, but essentially I'm drawing arrows here, okay? And the idea is we would use this top formula if we're finding the Laplace transform, and we'd actually not use the bottom formula unless maybe it'll come out to look like that, as we'll see in our first example. But here, mostly the second one is a way to find the inverse transform. So that one for the transform, second one for the inverse transform. Alright, so we're going to find the Laplace transform of the function that we did in the last video. So we had a piecewise function and we wrote it like this. Okay, so get ready for some fun. Alright, so if we're going to find the Laplace transform of this, we're going to, like I said, we're going to use that top formula. Now notice we can use the second one on this one, because it's actually in that form. That's f of t equals t, where we're replacing it with t minus 1 and times u of t minus 1. So that's going to make that part a little easier. So, alright, Laplace transform of f of t. So this is going to be the Laplace transform of 1, which we know that's in our table. Okay, and then the Laplace transform of t minus 1, u of t minus 1, plus the Laplace transform of cos t minus t, u of t minus pi. That's going to be the one that's a little bit messy. Okay, so let's just go ahead and do this. So this would be capital F of s. Alright, but that one's one we know. That's 1 over s. Okay, and I'm going to write this using the top formula. Okay, I'm going to use this formula. So this says that the u of t minus 1 turns into an e to the minus s. And then I would be finding the Laplace transform of t. Now, let me stop for a second and say, why is that? Because t minus 1 plus 1 would just give you t. And this would be, as I'm looking at up here, this would be g of t plus 1, where a equals 1. Okay. And then, whoops, not equals, plus. Alright, this is going to give me u of e to the minus 2s. So the u of t minus t turns into that. And then I'm doing the Laplace transform of cosine of t plus pi minus t plus pi. Okay, so just one more step and we're done. Okay, so I get 1 over s here. Okay, everything's going to be pretty straightforward at the beginning. And then e to the minus s plus transform of t is 1 over s squared. Okay, and then the next one. Now, okay, this one's going to be pretty easy. This is cosine shifted pi to the left. Okay, that's half a period. That turns it into basically the same thing as negative cosine. But I'm just going to say here, when you have cosine and sine terms in this, you're going to need to remember the angle addition identities. Okay, so I'll say for the if we end up having a test on this, I'll say you probably don't need to memorize them for that, or you probably need to know them for that test. But I'd also say for the final exam, you're allowed the cheat sheet, so you can put that formula in your cheat sheet, so you don't need to remember it. All right, let me just keep going then. So this is e to the minus 2s. The transform for negative cosine would be minus s over s squared plus 1. And then minus, the transform for t is 1 over s squared. And the transform for pi would be pi over s. And there you go. That's the Laplace transform of a Heaviside function. And this would be one that I would say is considerably difficult. We'll see how much more difficult it gets when we actually solve a differential equation. because they're going to be long.